Okay, we're going to do 2.3, number 14. F of V is the gas consumption in liters per kilometer of a car traveling at V. So the F of V will give us the number of liters we use of gasoline per kilometer, and it depends on the velocity. So a higher velocity, there'll be more wind friction. So the number of liters that we use will increase with if we increase the speed, we're going to use more liters for every kilometer because there's more wind friction the car has to push against. Okay? How many liters of gas you use go 1 kilometer. In addition, they're going to tell you that if you're going at 80 kilometers, the V is measured in kilometers per hour. If you're going at 80 kilometers per hour, your use is going to be 0.05 liters per kilometer. Now, if you're not familiar, that's 0.05 is 5 hundredths or 1/20th of a liter per kilometer. In other words, you're going to use 1 liter to go 20 kilometers because you're going to use a 20th for the first kilometer, another 20th for the second kilometer, and so you're going to end up using 1 full liter to go 20 kilometers. Another way to look at what this is saying. Okay? And it says at 80 kilometers per hour, how this is changing is, now, if you start to go faster, it's going to use more, and so this is a positive amount. It's going to increase the number of liters you use per kilometer. And this number is 4 10,000ths, which is 2,500ths. But it's 0.0004 over 10,000, which is 1 over 2,500. Yes. This is the change in the liters per kilometer per the velocity change, because this is a derivative, it's a slope. So it's the change in F, and F's units were liters per kilometer divided by the X units, which are kilometers per hour. So you use 2,500th of a liter more. Remember, using 1/20th of a liter to go a kilometer. You're using this much more, that's the change in this, for every kilometer per hour you travel faster. So that's what this is all telling us. Now they want us to write a new function called G of V that is the distance the same car travels on 1 liter. Well, this is how many liters it travels to go a kilometer. So if I want the function says how many kilometers I can go per liter, that's just the reciprocal. That's this one upside down. So G of V is simply the reciprocal of F of V. However, the reciprocal of F of V, the derivative won't be just the reciprocal of F prime. we have to work it out using the quotient rule. So G prime is going to be the derivative of the numerator, the derivative of 1 is 0, times the denominator, minus the derivative of the denominator, times the numerator, over the denominator, squared. So if we're going to do this at 80, 0 times that, we don't have to worry about. That's 0. F prime, we know, is 0, and this is minus 0.0004. F prime times 1 over f of v, 0.05, 0.05 squared. And that works out to be negative 0.0004 divided by 0.05 squared. And we get negative 0.16. Now, what are the units? So the units of G were the distance car goes per liter. So that G's units are kilometers per liter, reciprocal of liters per kilometer. And V's units are kilometers per hour. So this unit is these divided. We go 0.16 kilometers per liter less for every 1 kilometer per hour higher speed. That's what this is talking about. Now it says H of V is the gas consumption in liters per hour of the car going V. Okay. And liters per hour. Well, F gives us the liters per kilometer. And if we want to get hours out of liters per kilometer, we need to multiply by something that has units of kilometer per hour, which is units for the velocity. So F of V times V will give us liters per hour. So H is F of V times V. So H of 80 is F of 80, 0.05, times the V, which is 80. So 1/20th of 80 is 4. That would be liters used per hour. And H prime, this is a product, so H prime of V would be F prime of V, the derivative of the first times the second, plus the derivative of the second, derivative of V is 1, times the first, and F prime is this number times 80 plus 1 times 0.05. So we have F prime 0.0004 times 80 plus 1 times f, which is 0.05. And we get 0.082. Now this is the derivative, so this was liters per hour per, and the velocity is kilometers per hour. So for every kilometer per hour faster you travel, we're going to get 0.082 liters used per hour more. It's going to increase the use of the field by this much. This is F prime, or this is H prime, the change in the liters used per hour for every kilometer per hour faster we travel. And I did the explanation of each of these as I went through them. Okay.